Our last presenter, Leyre, you are here. Leyre comes from the Delft University of Technology, and she is a PhD candidate in the Department of Urbanism, and also lead accredited professional. Like, maybe you say those two words about it.
Okay, so I will try to be really fast. The title of my presentation is Design Guidelines to Restore Thermal Balance in the Benelux. So basically, I think it's not just about, the framework is that I am analyzing the urban heat islands, so the temperatures basically, how using remote sensing technology, GIS and also design, where in the Benelux region and what for, in order to be able to provide some design adaptation guidelines. I think this is probably the most important slide in the presentation, because it means that we are analyzing invisible parameters in order to, with the new technology, in order to provide design guidelines. The idea is that we are doing this in the area of the Benelux. Typically, the heat island concentrates in the cities, and we compare the temperature in the city centers with the landscape temperature. But the Benelux area is a particularly interesting and relevant case for this analysis because of the low density and because of the blur boundaries. So typically this is the urban heat island scheme. My promoter Frank van der Hoeven spoke about it in the previous lecture. We have atmospheric heat islands, and we also have surface heat islands. The atmospheric heat islands can be measured from the top of the urban boundary layer or from the canopy layer. Just to keep it simple, because the scale at which we are assessing on this phenomenon is the regional scale, we will be assessing on the phenomenon from the urban boundary layer. Why is this a problem? I think as urban planners and in this summit, the importance of these or the relevance of the research is more that we are connecting, where we are using a new methodology in order to assess an invisible parameter, but there is also health relevance. And the World Health Organization already reported 70,000 excess deaths between June and September 2003, which was not the latest heat wave, but one of the latest heat waves that we've had. And we know there is a direct connection between the increase of mortality and the increase of temperature. So this is just to show in Paris how the mortality is related to the increase of temperature, particularly of the temperatures at night. Just to explain the phenomenon, we can see that by acting on the city materials and by acting in the morphology of the city, we can improve the thermal behavior of materials, and therefore we can help adapt our cities. This is a brick wall painted in white, so with a higher reflectance, higher albedo. We can see that the surface temperature measured on that wall we can see the effect not just of the white paint on top of the brick wall, but also we can see the effect of the shadow. Other factors that influence this phenomenon of the increase of temperature are the reduced vegetation, so the properties of the materials, the urban geometry, and anthropogenic heat. So if we look at the Benelux case, here we can see the daily land surface temperature in the region for the 19th of July of 2006, which was also another heat wave that we experienced in Europe. This is the daily land surface temperature. We can see that there are several hotspots that are indicated here with numbers that represent higher surface temperatures. And when we go to the night surface temperature map, we see that they disappeared. We can also identify a number of cooling sources. So some areas present this higher LST during the day and tend to refresh at night, and others present relatively higher LST at night than during the day. As far as the design guidelines are concerned, for the areas that heat up during the day and cool off at night, the design adaptation focuses in improving the thermal behavior of the public spaces in order to improve their comfort during the day. And the design guidelines for the areas that present higher temperatures at night focus in improving the thermal behavior inside the buildings, for example, by introducing cool roof coatings and so on. Now, we change of satellite, let's say, to zoom into particular cases. The relevance of this regional scale is that we can take best practices from one city to another and try to understand why they have a better thermal behavior. We have seen that we have problems identifying land surface temperature. Land surface temperature maps at night. And this is why we have to choose a different shortcut. So instead of using land surface temperatures maps, we will focus in the ground flux. If we look at the surface energy budget equation, we see that the net radiance equals the ground flux plus the latent flux and the sensible heat flux. So the ground flux actually reveals the amount of energy that is trapped inside the earth or inside the building. So when we go, this is the case of The Hague, we see that there's a high concentration of ground flux in the city center. And therefore, this is the area that we were asked to actually analyzed by the municipality of The Hague. So we saw that I had some slides with GIS, but I want to keep it short. So that the information that we retrieved with GIS is often very accurate for the assessment of the amount of water surfaces. But then when it comes to the assessment of greenery or the assessment of the different classification of roof types and so on, we encounter several problems. So the idea is that using the satellite imageries, we have generated this classification image that apparently doesn't mean anything, but that we will see that is far more accurate than the GIS results that we've been using, and that allows us to actually establish some conclusions. So the classifications that I used was wood, grass, water, asphaltic pavement, red, grey ceramic tile, soil, flat roof. So basically, it is a process. The classification is done by using different pixels in the satellite imagery, and basically it is an approximative method. So you need to do several in order to check whether it's correct or not, because it's an algorithm built inside the software. So we also have identified in the city center of The Hague the green vegetation index. So this is the area in blue we see that had a higher ground flux. That is the area that was trapping the largest amount of energy during the day. And we see that part of it, so this part, probably here, that there is a part that has a lower vegetation index than the other part. When we zoom in and we overlap it with the Google Earth imagery, we can focus on this area. So basically, to follow the reasoning, the idea is to identify what factors could be influencing the high ground flux accumulation in that part of the city center. So basically, it is important when we talk to the municipalities to be able to bridge the distance between the abstract data and what they actually see, so that they actually can confirm that what we are analyzing or what we are concluding is not just a methodology that we made up and that we think is validated, but that it's also, they can actually check it by themselves. So this is why we will zoom into these two axes. You see that there's absolutely no greenery in this Grote Marktstraat, and in the Wagenstraat, no greenery either. So, of course, these two are inside the area that was identified with very low vegetation indexes. This is an attempt to measure the length of these two streets, of these two axes, and this is precisely where we do the bridge between the analysis and between the design adaptation suggested, therefore, to the design. And it's always very complicated because, as urban planners, we think, or I think, that you cannot design just based on a thermal map or based on equations, because the reality is far more rich and complex. So we have to keep it very open, but at the same time we need to be able to provide benchmarks and thresholds and to be as accurate as possible. So to be able to quantify, I skipped like 1,000 slides, but I just want to be inside the 10 minutes. Basically, these are the results of the percentages of the different soil classification that I showed previously for two case cities, so the Hague Centrum and Delft Centrum. I didn't show the slide, but basically the Delft Centrum has a better ground flux behavior, so it has a better thermal behavior than the city of The Hague. So and this has been measured with the ground flux. So the idea is to compare the percentages of the different classifications of the different land use they have in order to be able to establish some parameters and to define how we need to act in The Hague in order to have a realistic threshold. Because otherwise we could say, well, I think you should just have more greenery, but compared to what? We have to bear in mind that we need to take as a reference a city that has a similar urban structure, that has a similar materialization in the sense that it's using the same materials and so on. So this is the reason why it is a work that has to be done within the same also climatic region. So it doesn't make sense to say, well, we take as a reference another city that probably performs a lot better, but to check one that has a better thermal behavior, but that is similar. So here we can see that The Hague Centrum has 4.85% of greenery, while Delft Centrum has 9.4%. This is the confirmation that, it has at least, since we are assessing the surfaces of the materials, we can see that the percentage of built surface, so the footprint of the built area and the footprint and the open space is kept similar, so it does make sense to compare these two. And I skipped like 1,000 slides. And the idea is that based on this, there is a suggestion of the amount of greenery that needs to be implemented in The Hague in order to be able to improve its thermal behavior in the center. This is just to show how we go from the analysis to the design measure. This has been done also for the albedo, so for analyzing the reflectance of the flat roofs, also for analyzing the reflectance of the sloped roofs. And the idea is that we provided the city of The Hague with a set of guidelines in order to intervene. The applications of this project is basically to develop a new technology to use satellite imagery in order to customize the solutions. So it is not that much the output, which is important, but basically it's also understanding that the satellite imagery provides us a very deep and precise understanding of the environment that we are analyzing. That the tools that we have been using as urban planners so far are not as performant or as accurate. It provides assessment on where to act, and the assessment in these times of crisis is to analyze before design, which maximizes the thermal impact of the measures. So it provides certain warranties that the method implemented is actually going to work, thermally speaking.
Thank you. Very interesting. Okay, I'm afraid that we are a little bit late, but I'm sure that you have some questions to our presenters. We had we heard to listen to 6 very interesting presentations, and there are really dozens of questions, but starting from this marvelous 3D software and visualization with the public participation, which is extremely interesting from my point of view, through many other topics. So maybe 2, 3 quick questions to our presenters. What do you think? Okay, we heard about that, the adequate data. And is there anybody who wants to ask a question? Because then we can go also, of course, for a coffee, and then you can use the presenters and ask them more questions. Maybe that's the best one. Daphne suggests this. Okay, so thank you so much for participating in this session, and hope to see you in the afternoon session as well. Thank you. I have a lot of questions too.
Sorry?
I have a lot of questions.
Now we can talk about that.
Yeah, because that's